Okay, so let's talk about NotebookLM. It's an absolutely fantastic research tool, right? It can handle a million tokens, it cites its sources, but it has this one giant frustrating problem. It's a black hole for your knowledge. Everything you put in gets trapped. Oh, and it can't do math at all. Today, we're going to fix both of those problems by connecting it to Claude Code and actually shipping a live app.
So what's the big picture here? Well, on one hand, you've got NotebookLM all by itself. It's powerful for sure, but it's basically a closed box. Now, look at what happens when you plug in Claude Code. Suddenly, everything opens up. You can bulk ingest sources, you can actually compute things, you can get your data out, and best of all, you can ship a real product. You're going from a simple research tool to a full-on research system.
So if NotebookLM is so great, what's the catch? Well, as soon as you start doing any real work with it, you smack right into two massive walls. And they completely stop you in your tracks. The first wall you hit is computation. See, NotebookLM is amazing at retrieving information, but it predicts answers. It doesn't calculate them. So if you ask it to do any real math on your data, you'll get back a very confident-sounding answer that is almost certainly wrong. So yeah, it really just boils down to these two fundamental gaps. First, there's no computation layer for crunching numbers. And second, there's just no good way to get your research out of the platform. No API, no download all button, nothing. It's a total one-way street. You know, there's a line from the source article that just hits the nail on the head. Your research goes in clean and stays trapped. I mean, it's the perfect description, right? Every single PDF and link you feed it gets indexed beautifully, and then it's locked away in a digital vault where you can't get to it. Okay, enough about the problems. Let's talk about the solution. We're going to break down those walls. I'm going to walk you through a 5-stage workflow that connects NotebookLM to Claude Code, frees your data, and turns it all into a live, shareable app that you can build in a weekend. So here's our game plan, step by step. First, we'll give Claude Code the ability to control NotebookLM. Then we'll bulk ingest all our sources, add in that numeric data it can't handle, export and vectorize everything, and finally, the best part, we ship a live application. First things first, you install an open source skill. There are a couple great projects like Please Prompto's NotebookLM skill. What these do is basically use browser automation to let Claude Code drive the NotebookLM website, just like a person would, only, way, way faster. And the payoff for that first step is immediate. Instead of spending, 45 minutes clicking add source for every video in a YouTube channel, you just give Claude Code a single prompt. It does all that tedious work for you in about 2 minutes. That alone is a massive quality of life improvement. All right, now for the big one, solving that math problem. We create what's called a computation layer by just feeding our raw numbers, analytics, financials, any metrics you have, directly to Claude Code. This is the stuff NotebookLM can see but can't really understand. With this in place, we can finally ask complex questions that mix our text-based research with our hard data.
Now, at this point, everything is still just living on your local machine. To make this research accessible from anywhere, for anyone on your team, we need to export it and build a proper, queryable backend in the cloud.
And we get pretty smart about this. We split the data into 2 streams. All the text, the transcripts, the articles, goes into Pinecone. That's a vector database, which is perfect for powerful semantic search, meaning you can search by an idea, not just a keyword. And then all the numeric data goes into Supabase, which is built for precise filters, aggregations, and calculations. The process itself is surprisingly straightforward. You use one Claude Code prompt to download every single transcript from your notebook. Then you tell it to chunk that text up and push it into your Pinecone index. And finally, you have it create a table in Supabase and just load in all your numeric data. It's pretty slick. Okay, we're on the home stretch. Our research is now free, it's structured, and it's queryable from anywhere. The last step is to get it out of the command line and into a simple user interface that anyone can access, even from their phone. The fastest way to get this built is with a really modern stack. We use a tool called Lovable to generate a deployable React UI just by describing it. We sync that code to GitHub, and then we just hand it over to Claude Code to write the backend logic that connects to Pinecone and Supabase. Now, to power the chat function in our app, we use OpenRouter. Think of it like a universal adapter for AI models. It gives us one API key, one place to set a budget, and access to dozens of different models. This lets us use the best tool for the job, like Claude's Sonnet, which really hits the sweet spot for quality and price on a task like this. So, after setting all this up, what's the big reward? Why go to all this trouble? Well, It's not just about the new features. It's about a massive, massive leap in efficiency. And here it is, the headline number, a 50x token savings. That's huge. Because your data is pre-indexed in Pinecone, you aren't stuffing gigantic transcripts into a prompt every single time you ask a question. This is a game changer for both cost and speed. And speaking of cost, you might think a custom system like this would be expensive to run. Not at all. The ongoing operational expense for a personal scale dashboard like this, using a tool like OpenRouter to manage your model calls, you're probably looking at around $5 a month. It's incredible. So let's just bring it all together. Think of it this way. NotebookLM is your amazing librarian, meticulously organizing all your information, and Claude Code is the brilliant analyst who can actually compute and act on it. By putting them on the same team at the same desk, you create a system that can ingest, analyze, and actually ship real products from your research. So the only question left is, what will you build with it?